First of all, we need to know the alarm of a Sunrui BWMS is divided into two types. First one is shutdown alarm. All shutdown alarms will indicate a pop-up window of the EDU fault. Like this picture, when the shutdown alarm happened, the information bar at the top of the screen will display the red and indicate EDU fault. When the shutdown alarm is eliminated, you should click Acknowledge. On the alarm page. Manually confirmed the alarm has been reset. After click Acknowledge, if there is still shutdown alarm, the pop-up window will come again. The second one is a warm alarm, which will not lead to system shutdown or pop-up window. The operator needs to respond as soon as possible and deal with the problem accordingly. Next, we will introduce the troubleshooting into 5 parts: EDU, ANU, AFU, TRO, and other alarms. First part, EDU troubleshooting. The first one is EDU cannot get water alarm. It may appear when the system is just started. On the top of the screen, the message bar will always display wait for EDU flow, and the value of EDU flow meter is always lower than the system startup flow. Usually, the alarm is delayed for about 1 minute. If the EDU still cannot reach the start flow, it will trigger the alarm and shut down. Different types of systems have different startup EDU flow rate. Please refer to the manual book. To deal with this fault, the first point is to check whether EDU inlet and outlet pipe are blocked. Second, check whether the boost pump works normally, suction and the discharging pressure is normal. The second is to check the EDU internal pressure and the dosing unit. Confirm the treated seawater in EDU buffer tank can be pumped out in time. If EDU takes water from the filter outlet directly without booster pump, it is also necessary to ensure the filter outlet pressure is less than higher than 1 bar to make sure the pipeline between the filter and the filter outlet valves is fulfilled with seawater. We can see this ballast pump. Ballast pump takes water from the sea chest, and water goes through the filter, and water goes through the flow meter and the filter. EDU takes a branch of seawater from the filter outlet through the valves and the booster pump, treated by EDU. Then inject back to the main pipeline through the dosing pump. If EDU forced to take water, first to check the pipeline is unblocked, or some manual valves along the pipeline are not opened. Secondly, observing the working condition of booster pump. Check whether pressure gauge fluctuates and pressure value is stable. Check whether pump pressure could be built to transit the seawater. Next, observe whether the pressure gauge of the dosing pump fluctuates and whether pump pressure can be established, same as the booster pump. Sometimes, pumps cannot pump water because the air contained in the pipeline. It is necessary to deflate the air in the pipe if system is not operating for a long time, especially the booster line. The next fault is the seawater leakage from EDU blowers. As below picture, this failure usually occurs in the old system, which may happen in the system before 2016. New design system will not happen. This is mainly caused by gas-liquid separation valve stuck in one position. Increasing water could not stop by valve and overflow from blower. In this position, it needs to open for cleaning to see if floater is stuck or lose efficacy. Secondly, check the liquid level meter of EDU buffer tank. After a long time, salt might accumulate at this position. Of course, the liquid level gauge could not display the actual liquid level, resulting in the mislead the system and cause the occurrence of water leakage. Next is the wind pressure switch cannot detect the wind pressure. The actual phenomenon can refer to below two photos. One is confirmed that EDU blower operates normally, but there is no wind pressure signal in this place. After time delays reaches, the EDU blower fault alarm will be triggered and the standby blower will start automatically. If there is still no wind pressure signal after the standby blower starting, the system will trigger shutdown alarm. In case of this problem, the first step is to check whether another standby blower has air leakage and whether the damper baffle is closed normally. Next, manually start the blower and check whether air blowing out of the front, the ventilation cap on the deck. If there is no problem with above 2 points, there is a high probability the problem occurs on the wind pressure switch. In EDU, it is on the upper part of the blower, near the hydrogen removal pipe. After opening the cover, you can see a big nut. The sensitivity of nut may be changed due to the vibration on board or other reasons. The nut can be adjusted up and down to achieve the wind pressure signal on when the start blower and the wind pressure signal off when the blower stops. EDU pressure sensor alarm, which is divided into two types, offline alarm and high alarm. In case of offline alarm, first check wiring. If there is installed another EDU, it can be exchanged with another EDU pressure sensor to confirm the sensor malfunction itself. Because the alarm of the EDU pressure sensor will lead to the system shutdown, it is recommended to prepare spare parts on board in case of the emergencies required. In case of detection high alarm, check whether the EDU pipeline is unobstructed or dosing pump works normally. Also pay attention to the pressure of the main pipeline. If back pressure of the main pipe has exceeded 3 bar, it may be difficult to inject EDU seawater into the main pipeline due to the capacity limitation of the dosing pump, which may happen when the buffer tank is almost full. Next is the electrolyzer high pressure alarm. In case of this alarm, first check whether seawater salinity is sufficient. If the salinity is low, the electrolytic efficiency will be reduced. BWMS will increase the voltage and current to produce enough oxidants. Therefore, the high pressure alarm of the electrolytic cell will be caused by this time. Secondly, the actual voltage at both ends of the electrolytic cell can be measured with the multimeter to confirm whether it is fault of the voltage transmitter. The transmitter can be found in EDU junction box. If direct measurement is dangerous, you may directly interchange the fault transmitter with another normal one to confirm the transmitter malfunction itself. Next one is the hydrogen sensor. It needs to be noted the zero drift of a hydrogen sensor is easily to occur within half an hour after system power on. If the alarm occurs within this time, zero correction is required to recover alarm. Hydrogen sensor is divided into two kinds of alarm, offline and detection high alarm. For offline alarm, first to check whether there is an alarm code shown on a local screen. It gives the corresponding guidance according to the code. Secondly, check whether the wiring, or directly swapped with another working normal sensor, confirmed whether there is a sensor itself problem. Most of systems install two hydrogen sensors in ETO. One is located in ETO degas chamber. One is installed outlet of vent cap on the deck. When occurred a detection high alarm, confirm whether the ETO blower works normally, or whether it is caused by the zero drift to trigger the false alarm. If alarm occurs in HS21, which represents ETO internal sensor, it is necessary to check whether the pipe leakage in ETO degas chamber. Next is the continuous sensor detection alarm and cannot be reset. It is because the hydrogen sensor contact with a high concentration of a hydrogen gas, which leads to the sensor crash. W04 alarm will be displayed on local screen. For reset W04, it is necessary to manually start the ETO blower and run for about 10 minutes to ensure that all hydrogen is cleared in the wet pipe. Then use the magnetic bar to scan the check mark on the local screen. The alarm can be reset. Here is a zero calibration video for hydrogen sensor for reference.
Remove? Yeah, remove. And then set Kelly. Cut here. To enter the manual.
Okay.
Yes.
Okay.
Okay. So just a bottom.
Okay.
The sensor is calibration.
Okay.
Wait, maybe.
It's calibration fresh air, huh?
Yeah, fresh air.
Okay.
Fresh air. Okay, maybe after 1 minute, you touch again.
Okay.
Yes, zero pass. Successful. So this one is the line with the calibration with the gas.
The next one is a chlorine sensor alarm. It should be noted that chlorine sensor requires a constant power on. As spare parts for storage, they need to be restored in an area with 5 to 10 degrees to prevent from the chemical volatilization in the sensor probe and lost detection activity. Similarly, zero drift is easy to occur within 30 minutes about the power on. When an alarm occurs, the wiring checks needs to be checked. Also, zero drift shall be considered. If detection high alarm triggered, first confirm whether there is the welding or painting work nearby. This volatility This volatility gas will be also detected and triggered high alarm by sensor. If it is caused by zero drift, zero calibration is required. ETO salinity low alarm. When the salinity low alarm occurs, the system will shut down automatically. The salinity sensor is located in the ETO inlet UPVC pipe. If salinity low alarm triggered, first need to check whether seawater temperature is relatively low. Low temperature will lead to the reduction of electrolytic efficiency. At this time, the heat exchanger shall be put into use to warm seawater entering ETO. Secondly, considering whether it is sensor itself malfunctioned. If vessel installed two sets of ETO, the salinity sensor can be exchanged to confirm the function. Finally, check the electrolytic cell voltage in the details of rectifier. If the voltage difference exceeds 3 volts, the deviation is too large, which may also cause the salinity alarm. Part 2. Troubleshooting of ANU. The first one is the pump head leakage from the metering pump. First of all, the metering pump is a diaphragm pump. If it is used for a long time, the diaphragm will be worn out and lead to cell failure. The water leakage can be handled as long as the diaphragm is replaced. If the leakage is oil, that means the oil seal damage and need to be replaced. The second, metering pump cannot pump neutralizer or the pump overload. It can be observed the TRO value during deballasting is always high and ANU liquid level cannot decrease. It is necessary to check whether the adjusting knob of a metering pump is in the correct position. Normal operation, the knob should be rotated to the bottom about 90% of the displacement. Turning the knob outward will reduce the displacement of a pump. When the pump is overloaded, check the lubrication oil of the metering pump, whether the lubricating oil is clean and sufficient. Replace the lubricant oil if necessary. Finally, it is also check the pressure gauge of ANU. Usually, the discharge pressure is set around 2 bar. Another possibility is that the pipeline of the metering pump is blocked by the salt crystallization, which can also be checked accordingly. The third part is the fault treatment of filter. First one is the filter differential pressure high alarm. First, confirm the small blue blow valve on the pressure pipe has been opened. Check whether the sewage pipeline is unobstructed. If confirmed filter is slightly blocked and caused a high DP alarm, it can increase the filter outlet pressure in customer mode and increase the back flushing efficiency according to reduce the differential pressure. If it is confirmed that there is no problem with differential pressure and the automatic back flushing has no effect, the filter needs to be disassembled for cleaning. If DP offline alarm triggered, check the wiring first. Secondly, purge the pressure pipe of pressure sensor with compressed air. Clean the accumulated salt, or it can be swept with another working normal sensor to confirm the sensor function. EFU outlet pressure sensor offline alarm. First of all, it is necessary to confirm whether the ball valve of the pressure pipe of sensor has been opened. Then check the wiring is normal. Usually, the alarm is caused by the back pressure in the filter. If the filter is fulfilled with water, the alarm can be disappeared by itself. This alarm can be ignored, indicating that that sensor is normal. Ball filter back flushing motor fault alarm. First, to check the current breaker settings in motor control cabinet. The current setting should be 1.2 times larger than the motor rated current. If there is no problem with breaker setting, motor can be rotated for 400 circles manually by head wheel, which back flushing arm moved one complete circle inside. Check if any resistance contained. If necessary, disassemble the filter for inspection. Filter safe filter motor fault alarm. Same as ball filter, which need to check the breaker setting. Filter safe motor breaker is usually set at 1.1 times larger than the motor rated current. Secondly, check the lubrication of the driving mechanism. Disassemble the filter and check whether the back flushing shaft is bent or suction nozzle shaft change to locate the shaft rocade. Filter bypass alarm. First, to confirm whether the bypass valve has been closed. If the valve is closed, check whether the limit switch installed on the valve is not touch the limit. If bypass alarm occurs during deballasting, the alarm can be ignored. The bypass alarm is only used for ballast operation. During the deballast, it is only recorded as a valve signal and issued notice alarm. The fourth part is TRO troubleshooting. TRO communication alarm. For non-explosion-proof TRO, which type is CLX-XT, mainly check the connection between the power cable and RS-485 communication terminal. Then check whether TRO communication address setting. Recently, if PLC implied Mitsubishi, TRO communication address is start from 5. Well, if PLC implies Omron, TRO communication address is from 1. Address change usually happen when ship staff change setting intention or change TRO devices. For explosion-proof type of a TRO, which type is CLX-EX2, due to an air sentinel installed for maintaining the constant air pressure in the TRO box to achieve the explosion-proof, it is also necessary to check the air pressure is sufficient. The air solenoid valve can be checked. If the valve is normal, check whether the cabinet is well sealed. Make sure there is no air leakage around the TRO box. If the air supply is confirmed to be normal, check whether the small ball in the ventilation cap of the air sentinel is dirty or stuck. Generally, reinstalled after cleaning can solve this problem. Next is the TRO sensor fault alarm. There are two most common alarms. One, this TRO cannot take water normally. WATR alarm code will be displayed locally in TRO. In case of this fault, first check the TRO water intake pipe. Confirm whether the sampling pump in TSU can take water normally. If the sampling pump can take water but TRO has no sampling water, the backflow valve along the TRO sampling line can be properly closed to increase the TRO in back pressure. Secondly, the black regulating valve inside the TRO can be adjusted. Check whether it is closed by faulty operation. The valve regulating is reversed, opening clockwise and closing counterclockwise. If the water alarm occurs during deballasting, appropriate to close the overboard valve and increase the back pressure of the TRO sampling point to avoid siphonage. The second TRO fault alarm is caused by the TRO sampling water discharge fault. TRO will display NPRG alarm code locally to notice drain failure. First, check whether TRO discharge pipe is gravity installed. It should be discharged directly into a funnel or similar container. Add the drain pipe from the TRO box should not be too long. Next, clean the TRO cuvette. Then check the TRO drain solenoid valve. It may be stuck and cannot be opened. TRO value exceeds the operation limit during ballast. First, need to confirm the reagent's expiry date and the storage condition. Prevent from the indicator over-oxidation. If TRO locally indicate alarm code, please refer to the above troubleshooting to eliminate the alarm. There is no error code. Check the reagent tube. If necessary, use the needle to drench the pipeline. Make sure the preselected pump can transit both reagents into the cuvette and no bubbles in reagent tube. Next, confirm the correct sampling valves has opened. Finally, check whether the circuit board or optics was corroded by seawater. TRO devices can be exchanged with another normal working TRO to confirm the hardware failure. TRO high alarm during deballasting. In addition to ensure the normal expiry date of TRO reagents, please check whether the neutralizer is still valid and the concentration is matched to the required standard. The neutralizer is valid for 1 month after preparing. If reagent and the solution are normal condition but TRO still high in deballast operation, then check the neutralization line. Make sure the neutralizer injects into the correct pipeline. Observe whether the liquid level of the neutralization tank drops normally when metering pump is running. And check whether the neutralizer has been pumped out. Generally, increasing the concentration of neutralizer can solve the problem of a high concentration of discharged TRO. Part 5. Other troubleshooting. Internal fault and the communication alarm of rectifier. Due to the rectifier is professional equipment which is not suitable for ship staff inspect on board themselves, it is recommended to feedback relevant photos of fault module to Sunrui for further analysis when the system is running. The photo includes the clear photo front view of a faulty module which indicates the error LED, module fault information displayed on rectifier local screen, and system alarm information shows on system HMI. Since each rectifier has 2 modules as redundant design, therefore the failure or shutdown of 1 or 2 modules will not affect system in operation. So there is no need to worry. Feedback the photos we need, and we will provide further support. Pneumatic control valve failure. If system issue valve offline alarm, check the local position of power supply. If no power, check the power cable from the system cabinet. Manually open and close the valve and observe whether the display position of the positioner is correct. If the feedback is correct, check the feedback cable circuit. If it is incorrect, it is the fault of the feedback circuit board of the positioner. Next one is a pneumatic valve does not operate. First, need to check whether the valve engagement mechanism has chosen in automatic mode. Open and close the valve under manual mode to confirm whether the valve body is stuck. Due to our automatic valve are employed in pneumatic driven, check whether the air supply is sufficient. Around 6 bar is normal driven pressure. If it is the filter outlet valve malfunctioned, check whether the cylinder air bypass valve is closed. If there are no problems on above, the valve shall be calibrated under the guidance of Sunrui. If the pneumatic valve position feedback is incorrect or fluctuates badly, in addition to wearing inspection, further need to be checked is the connecting key at the bottom of the positioner. Connecting key is the damageable and mislead the position feedback of valve. If there is no problem on above, the valve shall be calibrated under the guidance of Sunrui. Next one is the valve leakage. Generally, water leakage usually happens at the connection between the valve body and the meshing mechanism, which is caused by the valve seat damage. It is not recommended to add gaskets if valve seat is rubber, which is easy to deform and damage the seat. Secondly, check whether there are burrs on the edge of the valve plates and may damage the valve seat. The last introduction is the control screen is frozen and cannot be operated. First, make sure the screen is unblocked from the operation and the operating permission is given to the in-use screen. Secondly, it is necessary to check whether the PLC is crashed. which may confirm by clicking screen, but no response, and the PLC CPU module indicates error LED lights. It can only be reset by rebooting the system to restore the crash. Generally, PLC crash is usually caused by GPS communication bit transit change. At present, the standard procedure have been optimized. It shall be not happen in new projects. Finally, check whether the communication line of the screen is connected falsely. That's all for troubleshooting. If you have any questions or need further guidance or communications, please contact with us through the ship service email. Thank you.